Okay, we are doing 9.5 polar coordinates. So if you notice, this is kind of a little bit of a section about looking at different ways of graphing. So yesterday we did, oh my goodness, what did we do yesterday? I totally blanked. We did parametric equations. Today we're going to look at polar coordinates. Okay, so polar coordinates, we're going to look at basically a new way of graphing. So a new system of graphing. We have graphed up to this point always in rectangular or the Cartesian. Okay, so rectangular are the Cartesian coordinate plane. So that's, you know, the one we're used to where we have an X and a Y. And let's say it's 2, 4, and we'd go over 2 and up 4. We'd plot our point. That is what we're very similar, or very used to. That's what we're comfortable with. With our new system, we're going to do in, you probably guessed it, polar coordinates. And polar coordinates are very similar to polar vectors. So a polar coordinate is going to have an r and a theta. R is going to be a radius, and theta is an angle. Okay, this looks like polar vectors, but with coordinates, we're not drawing a line. We're actually looking for a point. And with polar coordinates, we're going to have something that looks like this. Okay, with these today, you can either freehand them, or you could go print out different versions. So here's a couple versions that I found online. I think you're fine just freehanding it, but if you're one of those people who, like, needs a little graph, sometimes I just struggle. I need the graph already drawn because I'm not very even with my tick marks. You could print these out. So if you notice, on a polar coordinate, we have this circular shape. The center, if we were talking about a Cartesian, the center is your origin. This here, our center is the pole. Okay, so origin, pole. So if we have polar coordinates, we might have something like 545 degrees. So the way we think about polar coordinates is the idea of we're standing here at the pole, just standing there, and we always start standing 0 degrees. So we're facing 0 degrees standing at the pole, and we decide to turn 45 degrees. So we turn 45 degrees, and then we walk out 5 spaces. So we walk out 1, 2, 3, 4, 5. So that's the point, 545 degrees. There's my polar coordinate. Okay, so we're going to be graphing quite a few polar coordinates today. Sorry, this is my high-tech whiteboard. I just put it in plastic and it got moved around. Okay, so yeah, fancy. Okay, so we're going to just practice graphing a few polar coordinates. So we did the 545. So let's do another one. Let's plot 3. Oh, you can't see that. Okay, we're going to plot 3 and 5 pi 6. Okay, if you notice on mine, it doesn't have the radians, so if you're not sure what 5 pi 6 is, you can look at your unit circle, or you can change 5 pi 6 to degrees. If you look at your unit circle, we know that that is 150 degrees. So again, you start at the pole, facing 0 degrees, you turn to 150 degrees, still at the pole, and then you walk a positive 3. And there's our point. Okay, what if I had 5 negative 90 degrees? Okay, So again, we start facing 0 at the pole. We're going to this time turn negative 90 degrees, so we're now facing down, and we're going to walk out a distance of 1, 2, 3, 4, 5. Okay, so far so good. What if we had negative 6 and 210 degrees? Okay, so if we go negative 10, so we're going to go, sorry, got distracted, we're going to go 210 degrees, so facing 0 at the pole, we're going to go all the way over here, we're now facing 210. Okay, but if you notice we have a negative 6, so we're now facing 210, but instead of walking positive 6, we're like walking backwards. 1, 2, 3, 4, 5, 6. Okay? So negative 6, 210 is over here. Okay? So again, we started facing 0 degrees at the pole. We turned all the way to 210 degrees, but because we're going negative 6, it's like we're walking backwards. So if our radius is positive, it's like we're walking forward. If our radius is negative, we're walking backwards. Okay, let's do one more. Running out of colors. Let's do negative 4 and 7 pi fourths. Okay, so 7 pi fourths. So 7 pi fourths we know is pi fourths short of 2 pi. So, sorry, my lights went out. So that's going to be right here at 3/15. So we're going to start here at 0. Okay, or at the pole, facing 0 degrees. We're going to turn, so now we're facing 315 degrees, but instead of walking forward, we're going to go back negative 4. So we're going to walk backwards 1, 2, 3, 4. Okay, so those are polar coordinates. Cool thing about polar coordinates, though, if you notice, there are lots of ways to get to this point. There's tons of ways to get to each point. There's actually infinite ways to write these points. We're on a Cartesian coordinate plane or on a rectangular coordinate plane. We're kind of limited to one. So let's look at all, excuse me, all the different ways we could get to different points. So we're going to do the point, let's do the point 545. Okay, and we're going to write this in 4 ways. Okay, so I'm going to rewrite this. So we're at 45 degrees and we're up 1, 2, 3, 4, 5. Okay, so I want to write another way to get to that point. So let's think about this. So what if we went 45 and up 5? What if we went negative and then positive? Okay, so let's look at our first option. So let's go negative. So I'm going to start here, and I'm just going to draw it out here. But I want to go all the way negative, so I'm on this line. So I'll be here, but I'm going to be facing this direction. So I go negative, and then I'm going to go positive 1, 2, 3, 4, 5. So I'm going to go 5, and then how do I figure out what angle that is? Well, that's 100 or 360 minus 45. So if I do 360 minus 45, that's going to give me 315. But we want negative 315, so negative 315 degrees. So if I go negative 315 degrees and then forward 5, I will get to that same point. Okay. What if we had a negative radius? Okay, let's say we have a negative radius. So that's the idea of walking backwards. Okay. So real quick, just make sure we're good. We were here at 0 for the green one. We were here at 0 and we turned all the way to negative 315. So because we're turning, 0 turning, oops, you can't see it, but turning, you walked forwards. Okay? So this time we want the idea of walking backwards. So what if I went positive? So what if I go positive here? So I'm start at 0, I go positive. So I'm now facing this way, but then go backwards 5. So let's think about this. I want to be on this line, this angle or facing, and I'm going to go positive, let's see, 180 and 45 more, so 225 degrees, but back 5. So I turn positive 225 degrees, so positive 225 degrees, and then back 5. I will land on my original blue dot. Okay, so we've got a positive radius, positive angle, positive radius, negative angle. We have a negative radius and a positive angle. Probably you could guess what comes next. We are going to do a negative angle, negative 5, negative angle, negative radius. So again, I want this idea that I'm going to start and I'm going to go a negative direction and then walk backwards. So think about your marker. It's going to be facing, ooh, I don't know how to do this. So it's going to be facing out, and we're going to go a negative. So it's actually, we want it to land on this line or this position. And then we're going to walk back 1, 2, 3, 4, 5. So we want a negative 90 and 45 more. So that would be a negative 135 degrees. So if we went back negative 135 and then walked backwards 1, 2, 3, 4, 5, we would get to the blue dot again. Sometimes with these, honestly, it helps thinking about it as you're standing, thinking about standing on the coordinate plane, starting at 0 and turning a degree and either walking forward and backwards to get where you're trying to be on a coordinate or on a polar coordinate plane. Again, if you want to, you could print out this. Just Google polar coordinates graphs and they'll have a bunch of options, or you could freehand this. Just draw it, draw your circles and your different angles. If you notice, this one kind of has like our unit circle, and that should be good enough. Okay, on our next video we're going to be changing polar coordinates to rectangular and rectangular to polar.